I'm Joshua Bardwell, and you're going to learn something today. I've got two really cool pieces of tech to show you today. One of them is a stackable video transmitter and flight controller from what might be one of the best flight controller board designers in existence. And one of them is what might be the best all-around motor in existence today. And there's also a frame here. We'll review that too while we're at it. Stay tuned. Let me tell you how this video came to be. A guy from RocketCityFPV reached out to me. They're a retailer in, I think they're in Alabama, and they have a connection to the designer of the Moto boards. Moto is what I don't know what his real name is. And he said, hey, do you want to review this Moto board? And I really wanted to say yes. And you can see that I'm making this video. I did say yes. I've been a huge fan of Moto's designs ever since he came out with the very first, what is it, I don't remember what it was called. Cyclone, I think it might have been. He's always had amazing quality to his boards. He is a hell of a board designer. He puts in a lot of thoughtful stuff, a lot of thoughtful design features. We'll talk about what those are. And the boards, you can think of various manufacturers who have had problems, bad batches of boards, for example, like the very first SP Racing F3 boards had problems with, I think the capacitor placement wasn't right or something, and they were kind of popping in the field at an unusually high rate. And you can think of lots of examples of other vendors who had problems like that Airbot I'm looking at you. Moto, as far as I know, has never had anything like that. He is a really solid designer, and the quality control on his production is also really top notch. When his boards first came out, I didn't think they were for me. Oh, by the way, I think he was also the first one to do a board with a built-in PDB. If he wasn't the first, he was close to it. But his boards were not my thing when they first came out because the original one didn't have data flash, and I'm a big black box junkie, so it just wasn't my thing. But the Tempest flight controller, I was really happy to be presented with the opportunity to review this for you because it is my thing. It gets right all of the little complaints I had that were stopping me from fully loving a Moto flight controller. And I'm really thrilled to be able to share this with you. Hey folks, it's Joshua from the future here, and I apologize to you, and I apologize to RocketCityFPV who sent me this gear, and I apologize to Moto who designed the board, but I made a mistake throughout this video with the naming of the parts. Y'all remember that time when I reviewed the Armatan Chameleon, and through the whole video I called it the Armadillo? Yeah, it's kind of like that. So Moto has a Tempest F4 flight controller, and they have the Typhoon F4 flight controller and vTX combo. The Tempest F4 is a standalone flight controller. The Typhoon flight controller and vTX combo obviously are the stackable combo. And the Typhoon is what I'm reviewing today. I mistakenly sometimes refer to the Typhoon flight controller as the Tempest. And that yeah, you know how, anyway. So everything you're looking at today is the Typhoon. The Tempest is almost the same. I think it may be actually the same as the Typhoon, except that it's a standalone and it does not have the pins for stacking the Typhoon VTX on top of it. Okay, moving on. So here's the flight control stack all mounted in the frame, and yeah, we'll take a look at the frame as long as we're here in a minute. But this is the video transmitter right here on top. This is the Typhoon. It outputs 25 milliwatts, 200 milliwatts, and 500 milliwatts. It's a standard 40-channel video transmitter, not a 72-channel that transmits on the not quite entirely legal low band. Thank you, Moto, for doing the right thing. It has some cool features that you're going to like. One of the coolest features is also one of the simplest, and it really speaks to the thoughtfulness that Moto puts into his designs. Look right here. See this zip tie holding the IPEX connector on? Yeah, there's two little holes in the board, so you can put a zip tie down and it'll hold that IPEX connector on. You don't need to hot glue it. You don't need to epoxy it or anything like that. Just a nice little zip tie, and all it took was two little holes in the board. And hey, I hope if anyone else uses the idea of drilling two holes next to the IPEX connector so you can put a zip tie on it, that everyone remembers that Moto invented that idea and everyone else is stealing it from him. There's a connector here on the front for the camera. It just goes here, and it actually, you get a custom header here, and you can see it's pre-made to fit the camera. I'm not actually sure. I can't, how this, do you order these? These are custom made for your camera? I guess they must be. I haven't been able to actually figure that out from just looking around on the internet, but you can see this hasn't been soldered, so presumably they pre-make them with standard size connectors for the various, I mean, like RunCam, Foxeer, and how many more are there? So that's really nice. Again, a really nice, thoughtful touch that you don't need to. Another vendor might have given you a pre-made cutoff pigtail, and then you have to solder on yours, and then you got these ugly solder joints, and it's kind of a mess. Now you'll notice that there's an extra wire here. There's power, ground, video, and what's this extra wire? The extra wire here is for the OSD. That is not the Betaflight OSD, but the actual camera OSD, how you adjust the brightness and all the stuff in the camera. And the reason that's going to the video transmitter is that it's actually got a pass-through, so you can actually connect up your joystick for your camera OSD to the video transmitter, and it'll pass the OSD through, so you don't need to unplug the camera in order to access the camera OSD. And this is going to be really exciting in the future because Betaflight has a feature that it exists right now. It's not widely known and not widely documented, and yes, I'll make a video about it eventually. It has camera OSD control. Now, this was a feature that, as far as I know, was first invented by TBS, credit where credit's due, for their FP Vision and PowerCube stack. And what it lets you do is access the camera OSD menu from basically your goggles and your transmitter sticks, just like you're accessing the Betaflight OSD. It passes through the commands that the little joystick makes. Hang on, you know the joystick I'm talking about? It's this little thing here, right? It passes those commands through to the camera, so you can do that. You can do that in the field, and this is a real game changer. Nobody ever changes the brightness and the contrast on their camera because nobody wants to unplug their camera, pull out one of these things, and do that. But when you can do that from within Betaflight, it means that you can tune your camera settings to the lighting conditions more precisely. And in fact, I think that 6 months or a year from now, we're going to see like camera profiles where Betaflight OSD, you'll just say, choose my nighttime profile, choose my daytime profile, choose my indoor profile. I don't know, your own imagination. I should point out that there are a few cameras that do this already. I have one of the things I'm supposed to be reviewing that I'm way behind on is the RunCam Micro Swift 2. Here it is right here. It's the same as the Micro Swift, but it's got an OSD, like the Swift 2. It's got voltage monitoring OSD on board, and it has lighting profiles that you can switch between. But you still have to plug in the joystick, as far as I can tell. Yeah, sorry, RunCam. I know you sent me this like 2 weeks ago, 2 months ago. I haven't reviewed it yet. I've been super busy. The other thing you'll notice about the Typhoon video transmitters, we've got these dip switches here. Yes, dip switches. Those dip switches are for changing the output power. So it does not allow you to change the output power from the Betaflight OSD. You can change the channel. That's where you can change the band and channel like normal, but not the output power like you can, for example, with a smart audio. So you change the output power here with the dip switches between 25, 200, and 500. If we look at the underside of the board, we can see the pins where it interfaces with the flight controller, and you might be surprised to see an SD card reader here on the video transmitter, and that's the SD card reader for black box logging. The video transmitter and the flight controller can be bought separately, but they're designed to work together as a sort of a integrated whole, so the SD card doesn't go on the flight controller. If you buy the flight controller by itself, you won't have the SD card logging. And here is the Tempest F4
Typhoon
flight controller. As I said in the intro, I'm a really big fan of Moto's design, both in terms of hardware design, where he designs boards that work really well, that don't fail in the field very much, and that perform well. Like, for example, he's got an MPU 6000 gyro on this. Now, that's not one of the new fancy schmancy 32 kilohertz gyros. It's just the one that's actually the best. So screw marketing. Except for those of you who really know, the MPU 6000 that's actually good marketing. So let's talk about what's nice about this board. All of the pins and plugs that you're going to need to get at are right at the edge of the board. Some designers stick those things sort of on the center of the board for reasons I don't know why, just because they can't fit them anywhere else, right? Well, Moto put the thought into it. One complaint that I do have is that none of them are really, well, they got the plus and the minus there for ESCs, but none of these ones here are silk screened. It would have been really nice to be able to have those silk screened on there. Of course, you can see there's just not really any room for it. So you do have to refer to the pinout diagram when you're soldering it up. And you can imagine that it would be really easy to sort of accidentally get one of these wrong. So just be real careful as you solder it up. Make sure you're looking at the board the right side up. You're not looking at the pinout diagram for the bottom side instead of the top side. And just make sure you solder everything where it needs to go. Moto's passion for great hardware design extends to the way that the video transmitter is powered. You don't need a bunch of filtering and a bunch of capacitors with this setup. And one reason is, as I said before, he used the MPU 6000 gyro chip, which is the most noise resistant or the least noise susceptible gyro chip. You sometimes have to soft mount an MPU 6000, but you're the least likely of any gyro that's used on a flight controller today with the MPU 6000. And then the power supply to the video transmitter, of course, is integrated, and it's filtered and capacitors and all the things that you need to do to ensure that your video is as clean as possible. Obviously, some copters out there are so noisy that nothing will look good, but this combination is potentially the most noise resistant of any flight controller and video transmitter on the market today. Well, specs for this flight controller say that it supports up to 6 D-shot motor outputs, and that's surprising because most flight controllers don't have enough DMA channels to handle more than 4 D-shot motor outputs. If you don't know what a DMA channel is, well, suffice it to say, you need 1 DMA channel for every D-shot motor you're running. So even if the flight controller does have 6 motor outputs, like, for example, the Holyrow Kakute AIO or the Kakute F4, it can't actually do 6 D-shot motors at a time. If you want to do 6 motors, you have to use multi-shot. Although the specs say that the Tempest F4 supports up to 6 D-shot motor outputs, I can't find more than 4 actual motor outputs. So I guess they're assuming that you're going to use resource remapping to reassign something like the LED strip pin or some other pin and use that as if you wanted to run 6 motor outputs here. So that's kind of a cool feature, and that's the kind of cool thing that Moto's like, yes, my board will do this thing that no one else does. Yeah, will you use it? I don't. If you're running a hexacopter, you might really like that. Now, as I go to reassemble this, you'll see one of the things that I don't like about this frame, and I apologize to the frame designer for starting with the thing I don't like, but it just happens to be where it falls in the review. I'm not going to take it apart again to get to it, and that is that these are this I like. These are some 3D printed TPU, presumably. They hold the flight controller, and they presumably also provide some vibration isolation. That's very nice. But the way that the board mounts to it is that you've got these screws going up through the bottom. I'm not sure if the camera is picking this up, but they don't go up from the bottom here, right? They go up from the bottom here. And so in order to get this back on, you kind of got to stick your fingers underneath. You got to slide the board up a little bit and get your fingers under here, and there's just doesn't really seem to be a way to get a screwdriver in there. Once the motor wires are soldered on, of course, you can't really do that. So granted, these don't need to be in very tight. They just need to hold these guys together. Oh, there we go. I gotta make sure these pins line up correctly. There we go. So it's not the end of the world. It's not like it's really a massive structural component, but it is annoying, and it's the kind of thing that just makes you go, what were they thinking? Like, to make me have to slide this up like this to get at the screws. Like, maybe you could put a pass-through hole in the bottom plate somehow, and it's not a big deal. But it's the kind of thing that turns me off a little bit. Like, I really am excited by thoughtful design, and the Moto flight controller has a lot of that. When I see something like that, or it just makes me go, like, did the guy who designed this actually think about how it's going to be used on a day-to-day basis? And that kind of bumps me out a little bit. And it's not just that it's a little tough to get at the screws, right, to hold it, but once you remove the nuts, the screws want to fall out, you know, so, yeah, just seems like an oversight. How often will you have to do that? Well, I mean, as you can see with the video transmitter on top, you have to take it off every time you want to solder on a new wire or, you know, do any kind of repair, which, okay, that's fine. You know, the video transmitter has to go somewhere, but having to go through this rigmarole with the screws every time you do it is a little bit, it's not the best. So now that's back in place. It is a really nice clean build. I like the way Moto designs his flight controllers with, they're all through holes, even the ESC and the power wires and stuff. And then the way he typically builds them and recommends they be built is that the wires come up from the bottom and then soldered from the top. And it really does just make for a really nice clean wiring, clean build. I also dig this design. I'm seeing more frames do this with the video transmitter antenna mounted to the bottom plate and just kind of sticking up behind the back of the frame. You'll see how it is when I put it all back together. I really dig that. It keeps it out of the props. It lets it come up above the top plate a little bit, so you still get some good clearance. And it means that also if something comes along and shears off the antenna, it just bends back. It doesn't break. So it really does seem like a really nice place to mount it on the bottom plate like that. So then while we're here, let's talk about the frame. This is the Focus 220 V2 frame. And this frame was actually designed specifically for testing the Moto flight controller. So it's really been designed around this flight controller, although of course you can use any flight controller you want. It's marketed as a racing frame, but the weight, I'm not sure I believe them. If we look at it here, it's been on for a while. I'll run down that battery. If we look at the weight here, 301, 325, 330. So 330 grams with no props. And that's perfectly respectable. That's nothing to be ashamed of. But for like a racing quad, 330, let's see, add another, say, 150 for a battery, roughly 330, 430, 480. We're still under 500. It's okay. Yeah, if you choose to put a GoPro on it, although you probably wouldn't for racing, you're going to be under 550. So that's a light quad. But maybe I've been spoiled because I've been seeing quads like the Catalyst Machine Works Norris or the Leggero even, and they're coming in closer to 250, 270, at which point 330 is not as impressive anymore. So here's something pretty cool. The camera is in a TPU 3D printed mount. And it's the entire front end of the copter. So here's these little tabs here, right? And the tabs go into the slots on the base plate. You can see right here. There they are. And then the top plate goes on, and it's got similar tabs and slots. And then, of course, 4 screws go in the standoffs. And there you go. Now, at first glance, it really looks like this copter has a nice big bumper protected front end, but I'm not convinced that's actually true. If you think about the angle you're going to be flying at, right, there's nothing really protecting the camera. I mean, you're protecting the carbon. This TPU is protecting the carbon, but the camera feels like it's not as protected as it might feel like it is. There's nothing like a standoff to really take the force of any impact. And in fact, the lens is right out front. Obviously, flight testing will reveal, but it's a clever design. I kind of dig it. I kind of wonder if these 3D printed tabs are eventually going to wear off if you crash enough times, if that's going to get loose or anything like that. But I dig the innovation. I dig the thought behind it. I just question, I'm not 100% sold that it's a good implementation. The antenna that's provided is this Pagoda, and I'm a huge fan of the Pagoda. I think the Pagoda design is the best FPV antenna design available today overall. The problem is that it's really hard to manufacture a Pagoda to the right tolerances. It's really easy if the plates are not aligned exactly right, or if you've got a cover on it that it changes the dielectric, etc., and the tuning changes and the performance goes. It's a really finicky antenna. For example, we've got this 3D printed plate here, and that is really slick. That's going to keep these aligned perfectly, but is the 3D printed plastic itself somehow changing the tuning of the antenna? I don't know. So I love this antenna, and I think they've done a really clever thing here by doing this. I wonder sometimes if we're getting the most performance out of our Pagodas because it's so fragile, we put a cover on it, and then that changes the RF performance. The motor on this build is the T-Motor F40III, and it is a 2306 sized motor. And if you look here at the bell, you probably can't read it. It's the one that they sent me is 2750 kV. And so the immediate comparison that springs to mind is to the Emax 2306 2700 kV. that I have concluded is just pointless because of how many amps it draws. At least pointless on a mini quad. Maybe it'd be good for like a wing or something where you only have one motor to feed, not four. I haven't flown this motor yet. Like I said, this is a bench review, not a flight review. A flight review will be coming. But I have hopes that this motor will be okay. Unlike the T-Motor Pro line, like the T-Motor F40 and F60 Pro, which are really aggressive motors designed for performance at all costs. This motor it's kind of under-tuned. It's got weaker magnets. It's actually, I was talking to Ryan Harrell this evening, and he suggested he thought it had N48 magnets. So those are weaker magnets that make less powerful motors. Most motors today are using N50 or N52 magnets. But using the weaker magnets gives it more efficiency. And it's interesting to I looked at the 2400 kV version of this one, and I compared it to the Hype Train motor, which I've been flying quite a lot lately, on Mini Quad Test Bench. Mini Quad Test Bench is Motor Explorer. You can put two motors side by side on a graph and compare them. And with just about every single prop that Ryan Harrell tested, the Hype Train made a little bit more thrust than this motor, but this motor was just a little bit more efficient by about maybe 0.1 or 0.2 grams per watt. So very interesting to see how the 2750 kV version of this motor pans out. If maybe a little bit under-tuned motor in the same 2306 size could make that 2700 kV, 2750 kV rating palatable, we shall see. The T-Motor F40III is actually a really good all-around motor because it has the advantage of the larger 2306 size, the advantages that brings to the table, but it hasn't been hyper-tuned to the point where it just destroys batteries. In fact, I was talking to a prominent pilot who I won't name because he didn't give me permission to use the quote, who said that this was his pick for the current best all-round motor, just if you had to pick one motor to run. Not I don't think the 2700 kV version, though. I also was I chatted with Luke Bannister recently, and I asked him, hey, what are the racing motors that people are running? Just what's the new skinny in racing motors? And he pointed out that at the International Open in Muncie, the top 5 places of the racing were won by T-Motor, people running T-Motor. Either the F60 Pro, the F40 Pro, or the F43. I'm not sure which. So T-Motor is really knocking it out of the park lately, and this motor deserves some serious attention. I look forward to finding out how it flies relative to the Hype Train, and yeah, we'll have to see about that, though. Today is not the day for that. And that is going to do it for this review of the Moto Typhoon Flight Controller Video Transmitter, the Focus Frame, and the T-Motor F40III motors. I've got some flight video of these motors coming up soon on the channel, and I will give you a little teaser and tell you that this exact copter hit 100 miles an hour, no joke, in a drag race. So yeah, but how do they do on the current draw? Well, you'll have to stick around to find out. Thank you for watching. Leave any questions you've got down in the comments. I'll answer them as quick as I can. And as always, happy flying.